Okay, so this lesson is about slope and slope-intercept form. Really go into the slope-intercept form. We're just going to look at the slope first. Okay, so when you're finding slope, if they give you, say, coordinate points. Okay, so let's say they give me 3, 4, and 5, 7 to work with. Okay, and they want me to find the slope of this. Now, that's why many different names. It's the steepness of a line. We call it the change in y over the change in x. The top part of your slope is going to be your vertical movement, part is going to be your horizontal movement. They also refer to that as the change, okay, or rise over run. So it depends on who's saying it and what they're talking about, which part of this I actually talk about. Okay, but so if they gave 2 points and I wanted to find the slope, we'll just graph the 2 points. So when x is 3, y is 4, we already talked about how to graph coordinate points. When x is 5, y then is up here, leave. Okay, and this would create our, let's say we were graphing an equation, we would end up with this line. Okay, but to count our slope, looking at is the rise over run. So you're talking about the vertical movement, counting from our first coordinate point where my second coordinate would be, how far up did it go. So you just, from here we went up 1, 2, 3 units. Okay, so that's my top part, my slope, which we usually write as an m. Okay, so my slope is going to be 3 on top, and then for the denominator, our run part, okay, we're looking at how far over we went. So from here we went over 1, 2 units, so 3 over 2. So that's your slope is 3 over 2, rise over run. And that's what we're really looking at. Now, if I didn't have time to graph it, I could use the formula. What we're really looking at is the difference between the two. So if you look at that y component, okay, the difference from 4 to 7 is 3, so you just subtract. 7 minus 4 would give me 3, that would give me my top component. And the same thing here, if you're looking at the horizontal, you're just looking at the difference between 2. So if we do 5 to 3, I would get 2, and that's the difference between the horizontal, which is x, sorry. Always use slope formula, which is on the test, memorize it. Okay, so something like this. Okay, and they wanted me to find the slope, I could use formula. y2 minus y1, x2 minus x1. So when I do that, it doesn't matter which point you decide, the first or the second, it all works out the same. Okay, so I'm just going to call this x1 and y1. If you decide that this is going to be a point, will have to be 1s. So this is going to make this point 2, so x2. Okay, so you just get those labeled and then you plug in your values. So our slope here is going to be, now be very careful with your signs, it is negative 4. We have the minus from the equation, and y1 was positive 2. Okay, x2 is negative 1. There's a minus equation. x1 is negative 2. So be very careful there. I had 2 negatives, subtracting a negative number, which of course adding. Negative 4 makes negative 6. Negative 1 plus 2 becomes negative 1. Okay, so my slope is just negative 6, because 6 over 1 is 6. You do reduce. If it's a fraction, you're going to reduce negative 6 to 6. So that'll be my slope. And you can, if I go and I plot these 2 points, this is negative 2, positive 2, there's 1. When x is negative 1, y is negative 4. There's the other. Okay, so when I draw my graph, I'm going to actually use a card this time to make it a little more accurate. Draw my line with my arrows on both ends. Okay, you can see that these here, see it's negative 6, so down 6, because negative makes it go down. 1, 2, 3, 4, 5, 6, down 6 units. Okay, 1, 2, 3, 4, 5, 6. And we went right 1 unit, 1 pause. Okay, so that works out, that checks out the slope 6, down 6 over 1. Okay, so same thing here. Okay, if I did x1, y1, x2, plug it into my formula. y2 is negative 2. My y1 is negative 4. Okay, x2 minus x1 is negative 3. And watch your signs, that becomes negative plus 4, 0 plus 3, which is just positive 2 over. Okay, and again, you can check this with your graph. It's negative 3, negative 4. There's 1 point when x over y is negative 2. There's the other. Draw my graph. throw my arrow ends. Okay, and you can count. So when I went up 2, right 3 to my next one. And if you kept going with this, you could keep counting up, right 3, and you should end up on the graph every single up 2, right. Okay, so you can kind of see how that works. I could also go the other direction, down 2 and left 3, because that makes a double negative. And when I go 2 negatives together, it makes a positive. So down 2 and 3, that would make negative. Left is negative, so that makes a positive graph. Okay, so that slope looks. Sometimes they just give you this, find the slope of the line through those points. So you just plug it in, always label them. I've been doing this forever. I still label them just to make sure that I don't accidentally switch them around. Okay, because once you've decided that this is 2, they have to both be 2. Once I've decided this is 1, they have to both be 1. I can't switch and have x1 and y2, x1 and y, or x2 and y1. That doesn't work. Okay, so we've got y2 minus 1, x2 minus x1 becomes 4 plus 2, 2 plus 1, 6 over 3, which is just 2. Okay, so the slope there is just 2. Sorry, I'm kind of awkward here. There's just, okay, so here, find the slope of the line y is equal to -1. So let's say I graph this. Let's graph this. Negative, it'd be a horizontal line at -1. Okay, because it says that y is -1 all the time. It doesn't matter x values I choose, I always get y is equal to -1. That's all y ever equals. So that's why it makes this horizontal line. So now, if you think about the slope of that line, okay, the slope of that line. Well, let's just say I picked point. Okay, let's say I pick, and it doesn't matter, so let's say x is 0, y is -1. So there's 1 point, we'll use 0, -1. How about, I don't know, or -1. Okay, so when x is 4, y 1, I could have changed 8, -5, 1. Okay, all of those points lie on this horizontal line, because it doesn't matter which x value I choose, there's nowhere to even plug it in, so I just get y equals -1 for all of them. Okay, so now let's use our formula to do that. Slope is equal to, I'll call this x1, y1, x2, 2 minus y1 over x minus x1. Okay, so put that together, -1 minus -1, -1 plus 1, which gives me 0 over 4. Okay, and 0 divided by anything is always 0. So the slope of a y equals is going to be 0. Horizontal lines always have a slope of 0. Okay, so it doesn't matter where you put them, they're always going to have a slope of 0. Sorry, I can't write and talk all at the same time, apparently. Okay, so they always have a slope of 0, which sense? I mean, how steep is this thing? It's not. It's perfectly flat ground. Okay, there's 0 slope in this thing. It's perfectly flat. Okay, now this, however, looks a little bit different. Okay, slope of the line x is equal to 5. Okay, so we come over here to where x is equal to 5, and it doesn't matter which y value in, I always x is equal to 5, because x is equal to 5 all the time. So here's my line where x is equal to 5 all the time. Okay, so no matter which value I choose, if I go up here to y is 4, x is 5. 0, x is 5. -5, x is 5. So it doesn't matter which x value I choose, which y value I choose now, x is always going to be 5. Okay, so same thing. Let's just pick a couple. So let's say I use 5 and 5, -4. Okay, so we're going to x1, y1. Oops, wrote that wrong. See, that's bad. It's bad. It's got to be x1, y1, x2, y2, and then you plug it in. So -4 minus 2, positive 5 minus 5, -6 over 0. Okay, well, we've already discussed it. Remember that whenever you try to divide by 0, that's that's undefined. That's an undefined. Okay, so since it's undefined, that means the slope of my graph is undefined. Okay, so if they ask what slope of any vertical line, it's going to be undefined. So we'll put that underneath the lines always have a slope of undefined. Okay, you can also call that no slope, which is then a zero slope. Okay, zero slope and no slope are very different, so you have to be careful there. No slope is when we run into a brick wall. Zero slope is running along flat ground. So, okay, that's kind of the difference between those two there. Now, these are just some general things. Negative slope, okay, which means it's going down. Move from left to right, increasing. Okay, as like a book, from left to right, it goes down. That's a negative slope. Okay, positive means as I go from left to right, we're going uphill. Okay, so we're going uphill. Zero slope, we just talked about perfectly flat ground, and undefined or no slope is when you brick wall. Boom. Okay, so parallel lines. Okay, we're going to look a lot at parallel and perpendicular. We're going to do a lot of writing equations using parallel and perpendicular. Okay, when you have parallel lines, that means they have the same slope. The most important part about parallel lines is they have the same slope. They have to in order to stay parallel, because if they had different slopes, eventually they would run into each other because they're at different. But if they're at the exact same angle running next to each other, then they've got same slope. They are parallel. So, example would be right here. Y is equal to negative 2x plus 5. So let's say this is our y-intercept, this is our y-intercept, and it's got a slope negative, it's got a slope 2. Okay, it looks around about right, so we're just kind of guesstimating here. So then the other one, which goes through the origin, would just negative 2x. Okay, but they're the same slope. That's the important, okay, the exact same slope. So if they have the same slope, those are called lines. Perpendicular, however, have the exact opposite reciprocals. Okay, has to be opposite reciprocals. We've already heard those words. Opposite change in sign. Okay, and reciprocal is where you flip it over. Okay, opposite and reciprocal. So let's say I have y is equal to 4 minus 3/2 x. Okay, we'll call it f of x. No, we won't call it that. We'll save the function notation for later. Okay, but this first one right here, okay, is 4 minus 3/2 x. Okay, so if we had like this, which, let me rewrite it properly. Negative 3/2 x plus 4. That's an appropriate way to write it, right? Mx plus b. So, if I have this, y is equal to negative 3/2 x plus 4, okay, then the perpendicular line is going to have the opposite reciprocal. So for the perpendicular, you take this and flip it over and change the sign. So now positive 2 over 3x. And then here doesn't really matter. This particular one looks like it goes right about minus 1. Okay, so you're looking at kind of where it's through. So negative 1, but it's going to have a positive because it is increasing. This one was decreasing, so that looks about right. We can get rid of this one. We don't really need that there. Okay, so this is the opposite and reciprocal. We usually just say opposite reciprocal. Okay, opposite signs and the fractions flip. That makes them perpendicular. Okay, one positive, one is negative. They have the exact slopes. So determine whether lines through each pair of points are parallel, or neither. Okay. This top part, we should have written slope here. Opposite and reciprocal slope. So since parallel and perpendicular lines both depend on the slope, okay? Parallel, they have to be the same. Perpendicular, they have to be opposite reciprocal slope. So here they're giving me points on line 1 and points on line 2. So if I know the slope of line 1 and I know the slope of line 2, I can determine if they're parallel or neither. Okay, we just talked about how to find slope. So we'll come up here, we'll call this x1, y1, x2. Okay, and let's go ahead and throw that. Okay, slope of, just for the sake of labeling, I'm going to call this L1. Okay, that way we can kind of tell what it is when we're looking back at our notes. So y2 is 3, y1 is 0. x2 is negative 2, x1 is negative 6. So we're just finding slope. 3 minus 0 is 3, negative 2 plus 6 equals 3, 4. Okay, so there's the slope of line 1. So let's find the slope of line 2. Same thing, x1, y1, x2, y2. Careful, make sure you don't accidentally mix the two together. That happens. Okay, so we're going to find the slope of line 2. That's what the slope of line 2. Okay, so we're going to go 2 is 5, y1 is 1, x2 is 4, x7, solve, and we get negative 4/3. Here, the fraction has flipped, the sign has changed. That makes them opposite reciprocal. Okay, two lines that have opposite reciprocal slopes are to be perpendicular. Okay, so we'll do it again. So slope of 1, x1, y1, x2, 2. Okay, y2 minus y1, x2 minus x1, negative 5. 2 plus 1 is negative 5/3. Okay, so find the slope of line 2. x1, y1, x2, y2. 3 minus 6, 10 minus 5, negative 3, 5. So here, our fraction 5 3/5 negative. Okay, they can't be negative for it to be perpendicular, and they can't be parallel unless they're exactly the same, so this would be a neither. Okay, so then one more. Okay, let me draw a line and separate this. So slope of line 1, x1, y1, 2, y2. Okay, slope 1 is negative 2 minus 5 over minus 4, negative 7 over negative 3. Negative over negative makes positive 7/3. Okay, so then slope of line y1, x2, y2, 0, 7 over 1 minus 4, negative 7 over negative 3, which is a positive 7/3. Here, my slopes are identical, and since they're identical, that means that it is parallel. Okay, now this very last we've got here is they want me to actually identify a line that's perpendicular to the following. So they give me 2 points and on a line, and they want me to find the parallel slope, perpendicular slope. Okay, well again, the parallel and perpendicular has everything to do with the slope. So first we need to figure out what's the slope of this. So same thing. Here we go. x1, y1, x2, y2. Okay, slope of this is 6 over negative 1 minus 8. 3 over negative 9, which I'm going to reduce down to negative 1/3. Okay, my slope. So the slope of the parallel, is going to be exactly the same. Okay, and make sure you label them some way. Either write, you don't have to M and all that stuff. You can just write, and that's fine. But you have to label them so I know which. Okay, so then the perpendicular, you flip it over and change the sign. So it becomes 3 over 1. Negative becomes positive, so it's just 3. 3 over 1 becomes 3. So the parallel, there's my perpendicular. And that's all you're really doing for that, okay? I would suggest that you hit pause and try to do this on your own and see what you get, and then come back and check your answer with mine. I'm going to keep going, of course, because you can hit pause. In fact, you can rewind and play this thing as many times as you want. So here we go. x1, y1, x2, y2. Slope of this is going to be 5 minus 5 over 4 minus, sorry, I wrote it backwards. 2 is negative 1 minus 4, which gives me 0 over negative 5, which is just, okay, so it gets a little trickier, right? So slope of the parallel is still easy. Okay, the slope of the parallel is the same, so the slope of the parallel is 0. Okay, the slope of the perpendicular, however, well, once I take this and flip it, I've got negative over 0. Okay, but negative 5 over 0 is helps to spell. Undefined. Okay, so the slope of the perpendicular there is undefined. The slope of the is 0. Okay, and again, that's because when I flip, now I've got a 0 on bottom, which is not allowed in math. Remember, that's a big no-no. So then the last one here. y1, x2, y2, 3 minus 6 over 7 minus 7, with negative 3 over 0. So the slope of the parallel, okay, this here is undefined. Okay, this is undefined, which means the slope of my parallel is also undefined. And the perpendicular, okay, when I change the sign, I get over positive 3, which is just 0, okay? So that's all you're really looking at. So if one of the things is 0, the other one is undefined. Okay, so here my parallel was 0, so my perpendicular was undefined. Here my parallel was undefined, so my perpendicular had to be 0. Okay, that's all you're really looking at. Alright, so that's the end of understanding the slope and the slope parallel and perpendicular lines. And then we'll move into creating our own equations next section.